रेट लिमिट करून ये हो का इच्छा हवी जा. आता आपण वाचायला सुरू करू. Chapter 12, Design a Chat System. In this chapter, we explore the design of a chat system. Almost everyone uses a chat app. A chat app performs different functions for different people. It is extremely important to nail down the exact requirements. For example, you do not want to design a system that focuses on group chat when the interviewer has one on one chat in mind. It is vital to agree on the type of chat app to design. In the marketplace, there are one on one chat apps like the WhatsApp, office chat apps like Teams, or game chat apps like Discord, low voice chat latency. The first set of clarification questions should nail down what the interviewer has in mind exactly when she asks you to design a chat system. At the very least, figure out if you should focus on one chat or group chat app. Some questions you might ask are as follows. What kind of chat app shall we design? One on one or group based? It should support both one on one and group chat. Is this a mobile app or a web app? What is the scale of this app? 50 million daily active users. For a group chat, what is the number of group member limit? 100 people. How long shall we store the chat history? In this chapter, we focus on designing a chat app like Facebook Messenger with an emphasis on the following feature: a one on one chat with low delivery latency, small group chat, online presence, multiple device support, push notification. The same account can be logged in to multiple accounts at the same time. It is also important to agree on the design scale. We will design a system that supports 50 million daily active users. To develop a high quality design, we should have a basic knowledge of how clients and servers communicate. In a chat system, clients can be either mobile applications or web applications. Clients don't communicate directly with each other. Instead, each client connects to a chat service which supports all the features mentioned above. Let us focus on fundamental operations. The chat service must support the following functions: receive messages from other clients, find the right recipients for each message, and relay the message to the recipient. If a recipient is not online, hold the messages for that recipient on the server until the recipient is online. When a client intends to start a chat, it connects the chat service using one or more network protocols. For a chat service, the choice of network protocols is important. Let us discuss this with the interviewer. Requests are initiated by the clients for most client server applications. This is also true for the sender side of a chat application. It uses time-tested HTTP protocol, which is the most common web protocol. In this scenario, the client opens a HTTP connection with the chat service and sends the message, informing the service to send the message to the receiver. It also reduces the number of TCP handshakes. HTTP is a fine option on the sender side, and many popular chat applications such as Facebook used HTTP initially to send messages. However, the receiver side is a bit more complicated. Since HTTP is client initiated, it is not trivial to send messages from the server. Over the years, many techniques are used to simulate a server initiated connection, polling, or WebSocket. Those are important techniques widely used in system design interviews, so let us examine each of them. In polling, the client periodically asks the server if there are messages available. Depending on polling frequency, polling could be costly. It could consume precious server resources to answer a question that offers no as an answer most of the time. Long polling, because polling should could be inefficient. The next progression is long polling. In long polling, the client holds the connection open until there are actually new messages available or a timeout threshold has been reached. Once the client receives new messages, it immediately sends another request to the server, restarting the process. Long polling has a few drawbacks. Sender and receiver may not connect to the same chat server. HTTP servers are usually stateless. If you use round robin for load balancing, the server that receives the message might not have long polling connection with the client. It is inefficient. If a user does not chat much, long polling still makes periodic connections after timeouts. WebSockets is the most common solution for sending async updates from server to client. A WebSocket connection is initiated by the client. It is bidirectional and persistent. It starts its life as a HTTP connection and could be upgraded via some well-defined handshake to a WebSocket connection. Though this was through this persistent connection, a server could send updates to client. WebSocket connections generally work even if a firewall is in place. This is because they use port 80, which are also used by HTTPS connections. Earlier, we said that on the sender side, HTTP is a fine protocol to use, but since WebSocket is bidirectional, there is no strong technical reason not to use it also for sending. By using WebSockets for both sending and receiving, it simplifies the design and makes implementation on both client and server more straightforward. Since WebSocket connections are persistent, efficient connection management is critical on the server side. Just now, we mentioned that WebSocket was chosen as the main communication protocol between the client and server for its bidirectional communication. It is important to note that everything else does not have to be WebSocket. Most features of a chat application could use the traditional request response method over HTTP. As shown in figure, the chat system is broken down into three major categories: stateless services, stateful services, and third party integration. Stateless services are traditional public-facing request response services used to manage the login, sign up, user profile, etc. These are common features among many websites and apps. Stateless services sit behind the load balancer, whose job is to route requests to the correct service based on the request path. These services can be monolithic or individual microservices. We do not need to build many of these stateless services by ourselves, as there are services in the market that can be integrated easily. The one service that we will discuss more in is service discovery. Its primary job is to give the client a list of DNS host names of chat servers that the client should connect to. The only stateful service is the chat service. This chat service is stateful because each client maintains a persistent network connection to a chat server. In this service, a client normally does not switch to another chat server as long as the server is still available. The service discovery coordinates closely with the chat service to avoid server overloading. Third party integration scalability. On a small scale, all services listed above could fit in one server. Even at the scale we designed for, it is in theory possible to fit all the user connections in modern cloud server. The number of concurrent connections that a user server can handle will most likely be the limiting factor. In our scenario, 1 million concurrent users, assuming each user connection needs 10K of memory, is only needs about 10 gigabytes of memory to hold all the connections in one box. If we propose a design where everything fits in one server, this may raise a big red flag in the interviewer's mind. No technologist would design such a scale in a single server. Single server design is a deal breaker due to many factors. The single point of failure is the biggest among them. However, it is perfectly fine to start with a single server design. Just make sure the interviewer knows this is the starting point. Putting everything we mentioned together, we show the high level design. At this point, we have servers ready, services up and running, third-party integrations complete. Deep down the technical stack is the data layer. Data layer usually requires some effort to get it correct. An important decision we must make is to decide on the right type of database to use, relational databases or NoSQL databases. To make an informed decision, we will examine the data types and read-write patterns. Two types of data exist in the typical chat system. The second is unique to chat system, chat history data. The amount of data is enormous for chat system. Key value stores allow easy horizontal scaling. Key value stores provide very low latency to access data. Relational databases do not handle long tail of data well. When the indexes grow large, random access is expensive. Key value stores are adopted by other proven reliable chat applications. Data models, we talked about using key value stores as our storage layer. The most important data is message data. Let us take a close look. Shows the message table for one-on-one chat. The primary key is message ID, which helps to decide message sequence. We cannot rely on created ads to decide the message sequence because two messages can be created at the same time. Shows the message table for a group chat. The composite primary key is this one. Channel and group represent the same meaning here. Channel ID is the partition key because all queries in a group chat operate in a channel. How to generate message ID is an interesting topic worth exploring. Message ID carries the responsibility of ensuring the order of messages. To ascertain the order of messages, message ID must satisfy the following two requirements. It must be unique. It should be sortable by time. Auto-increment keyword in MySQL. However, no SQL databases usually do not provide such a feature. The second approach is to use a global 64-bit sequence number generator like Snowflake. The final approach is to use local sequence number generator. Local means IDs are only unique within a group. The reason why local IDs work is that maintaining message sequences within one-on-one channel on a group channel is sufficient. This approach is easier to implement in comparison to the global ID implementation. In a system design interview, usually you are expected to deep dive into some of the components in the high level design. For the chat system, service discovery, messaging flows, and online offline indicators was deeper exploration. The primary role of service discovery is to recommend the best chat server for a client based on the criteria like geographical location, server capacity. Zookeeper is a popular open source solution for service discovery. It registers all the available chat servers and picks up the best chat server for a client based on the predefined criteria. The user tries to log into the app. The load balancer sends a login request to the API server. After the backend authenticates the user, service discovery finds the best chat server for the user. User connects to the chat server through WebSocket. It is interesting to understand that the end-to-end flow of a chat system. In this section, we will explore one-on-one chat flow, message synchronization across multiple devices and group chat. User A sends the chat message to chat server 1. Chat server 1 obtains message ID from the ID generator. Chat server 1 sends the message to the message sync queue. The message is stored in key value store. If user B is online, the message is forwarded to chat server 2 where user B is connected. If the user B is offline, a push notification is sent from the push notification servers. Chat server is forwards the message to user B. There is a persistent WebSocket connection between user B and chat server. Many users have multiple devices. We will explain how to sync messages across multiple devices. Okay, nice. User A has two devices, a phone and a laptop. When user logs into the chat app with her phone, it establishes a WebSocket connection with chat server 1. Similarly, there is a connection between the laptop and chat server. Each device maintains a variable called current max message ID, which keeps track of the latest message ID on the device. Messages that satisfy the following two conditions are considered as new messages. In comparison to one on one chat, the logic of group chat is more complicated. Figures explain the flow. Figure 12 explains what happens when a user A sends a message in a group chat. Assume that there are three members in the group. It simplifies message sync flows as each client only needs to check its own inbox to get new messages. When the group number is small, storing a copy in each recipient's inbox is not too expensive. WeChat uses a similar approach and it limits the group to 500 members. However, for groups with lots of users, storing of message copy for each member is not acceptable. On the recipient side, a recipient can receive messages from multiple users. Each recipient has an inbox which contains messages from different senders. An online presence indicator is an essential feature for many chat applications. Usually, you can see a green dot next to a user's profile or username. This section explains what happens behind the scenes. In the high-level design, presence servers are responsible for managing online status and communicating with clients through WebSocket. There are a few flows that will trigger status change. Let us examine user login, user logout, user disconnection, online status fan out. In this chapter, we presented a chat system architecture that supports both one-to-one chat and a small group chat. WebSocket is used for real-time communication between the client and server. The chat system contains the following components: chat servers for real-time messaging, presence servers for managing online presence, push notification servers for sending push notifications, key value stores for chat history persistence, and API servers for your other functionalities. If you have extra time at the end of the interview, here are additional talking points. Extend the chat app to support media files such as photos and videos. Media files are significantly larger than text in size. Compression, cloud storage, and thumbnails are interesting topics to talk about. End-to-end encryption. WhatsApp supports end-to-end encryption for messages. Only the sender and the recipient can read messages. Interested readers should refer to the article in the reference material. Caching messages on the client side is effective to reduce the data transfer between the client and server. Improve load time. Slack built a geographically distributed network to cache users' data. The chat server error. There might be hundreds of thousands or even more persistent connections to a chat server. If a chat server goes offline, Service Discovery will provide a new chat server for clients to establish new connections with. Message resend mechanism, retry and queuing are common techniques for resending messages. Congratulations on getting this far. Now give yourself a pat on the back. Good job. Good job. Very good job. Goodbye. Very good job. End. Stream end. Stream end.